Welcome back on C squared. In this lesson we'll talk about angle bisectors and also about what's happened with this angle bisector inside of a triangle. And let's take a look to this definition. An angle bisector is a line segment or a ray that divides an angle into congruent parts. So you can see here in this picture the ray TA bisect the angle BAC into congruent parts. We can see they are marked the same way. This is an angle bisector. We have two theorems, and the first one is this one, angle bisector theorem. If a point is on the bisector of an angle, then it is equidistant. This is a keyword from the sides of the angle. Let's see what it means. Look at here. We have an angle bisector. We notice these two congruent angles, so that means TA is an angle bisector. This point T, which is on the angle bisector, is equidistant, the same distance. That's the reason I marked the same, with the same mark, from these sides of the angle. And you notice these angles are right angles because they shows us the distance between the point T and the sides of the angle. The next one is the converse of the angle bisector, which says if a point in the interior of an angle is equidistant from the side of an angle, then it is on the angle bisector. Look at here. This point T, if you notice, is equidistant, the same distance from the side of the angle. By the way, these are right angles. That's the reason we know it. This segment represents the distance from point T to those sides. They are the same. That means that T is on the angle bisector. Is the converse, the opposite of the previous theorem. Let's see some problem regarding this angle bisector. We notice in this problem, in problem A, we have an angle bisector because we see these two angles are congruent. That means these two pieces are congruent, so I think here I should have said G, this one should be also 12. Very simple problem, but let's justify the answer, and this is the first theorem we discuss about, the angle bisector theorem. Okay, let's take a look to part B. In this part B, what do we notice? We notice these two segments are congruent. Also, we notice that these two segments are perpendicular on the sides of angle TMN. So that means point R is equidistant from MN, the side MN, ray MN, and ray MT, which means MR is the angle bisector. So this angle here should be the same with this angle here, 27 degrees. And that is about this part B, and this is the converse of angle bisector theorem. This is the justification. On this problem, I said in some cases you have to use some algebraic skills, algebraic equation to solve your problem. Find the value of x if PF and PF if PF is 7x plus 5. So this guy here is 7x plus 5. And TF is 3x plus 21. This one is 3x plus 21. Justify your answer. So we notice here we have what? An angle bisector by the And now we justify our answer by the theorem that says if we have an angle bisector, then every single point on that angle bisector is equidistant from the sides of the angle. So now we know PF is congruent to TF based on, again, angle bisector theorem. Okay, that means also PF it's equals of TF, the measure of these two segments is the same, which allows us to write this equation 7x plus 5 equals 3x plus 21. I'm going to subtract 3x here to get rid of this positive 3x. So then we have here 4x plus 5 equals 21. I'm going to subtract 5 now to get rid of this plus 5. So I have 4x equals 16 divided by 4, x equals 4. So we finished the first part, find the value of x. Now we need to find PF. If we take a look, PF is 7x plus 5, so 7 times 4 plus 5. That will be 28 plus 5, and that will be 33. That's how much PF is. Okay, so let's move to the next example. And in this one, we need to find the value of x is the measure of angle, and the measure of angle VRS, this angle. If the measure of angle VRS is 3x plus 21, and the measure of angles PRS, this angle, it's 5x minus 23. Now, if you notice, I mark these angles the same. Why? Because RS is the angle bisector of the angle VRP. Why? We notice these two segments are congruent and they represent the distance from point S to RP, side RP, and the distance from point S to the side VR. So this point S is equidistant from these two sides, VR and RP. That means angle VRS is congruent with angle PRS, right? Because RS is an angle bisector. Okay. Okay. And now we know the measure of angle VRS equals the measure of angles PRS. So now we can write the equation 3x plus 21 equals 5x minus 23. Now I'm going to solve for x. I'm going to subtract 3x. And I have 21 equals 2x minus 23. Can I add 23 here to get rid of this minus 23? 21 plus 23, that is 44, equals 2x divide by 2, and that's the last step for finding x. X equals 22. So we find the value of x. Now we need to find the measure of angle VRS, which is nothing else than plug it in. And that will be 3x plus 21, 3 times 22 plus 21. That will be 66 plus 21. That will be 87 degree is the measure of angle VRS. Okay. Now we're going to move to the second part of the lesson, where we talk about the intersection of the angle bisectors of a triangle. And I said here, because there are 3 angles, obviously we have 3 angle bisectors. The point of concurrency, the point where these 3 angles bisector intersect, is called incenter. There is a property about this incenter. The incenter is equidistant, the key word, from the sides of the triangle. You're going to see that here. Point D is the same distance. You see these 3 segments, they represent the distance from point D to the sides are the same. The incenter is the center of the circle that goes inside of the triangle, and the sides are tangents to this circle I said here. Let's see how that looks. You look at here like that. Tangent means touch the circle in one point. The circle is called incircle. You see that here. Very important to remember, and it's easy to remember. Incircle, inside, inside. And the radii are called inradii. Now I have here the 3 situation. We have an acute triangle, and you see the incenter is inside of the triangle. The same for an obtuse triangle. The incenter is inside, and also the last choice is the right triangle. So it really doesn't matter what kind of triangle you have. The incenter and the incircle obviously are inside of the triangle. Now let's see some problem that are covering this topic. Point D is the incenter of triangle ABC. So you can put right away these 3 segments are congruent. Remember, these are the radii, the radii of the circle. Find the measure of angle DCE. We need to find the measure of this angle DCE. We need to find how long DE is, how long DF is, which are equals if the measure of angle DCF, this angle is 32 degrees. Now you notice I mark this angle the same as the previous one, because these 2 angles are the same. This is the incenter, so that means DC is the angle bisector. And like I said, DG is 5. So I think now we can answer to all these questions. I just need to justify. So let's start with the angle DCE. Angle DCE is congruent to angle DCF. And the reason is because we need to justify DCE is an angle bisector. Why? Because D is the incenter. So now we know the measure of angle DCE should be the same with the measure of angle DCF. So the measure of angle DCE is nothing else than 32 degrees. I'm sorry, DCE in fact. Okay, so now we can move to DE. And DE, as I said, is congruent with DF and congruent with DG. Why? Because D is the incenter. Incenter is equidistant from the sides of the triangle. Now, if we take a look in the problem, we know DG, so this one is DG. We know DG is 5. So now, based on this statement, we know DE is equals with DF and is equal with DG, which is 5. So now we have the answer for the last two questions. DE it's 5. Okay, and let me rewrite this again. DE is 5. And DF also it's 5. These are the radii of the incircle. Okay, and the next problem we have a very similar situation. Have point D is the incenter, so that means it's equidistant from the sides of the triangle, and the measure of angle FAD is 34. FAD, this is 34. DBE, this guy I'm going to mark different. This is 27 degrees. DG is 7. And FC is 9. We need on part A to find the measure of angle ECD. So we need to find the measure of this angle right here. And let's take a look how we do that part A. So on this part A, we're gonna use the fact that this point D is the incenter, so that means DB is the angle bisector, so this angle will be 27 also. So that allows us to find the measure of angle ABC. That will be 2 times 27, because we have those two angles of 27, so that will be 54 degrees. Very similar approach you're gonna do for this angle here. That will be 34, the same like the other one, because D is the incenter, so DA is the angle bisector. So we have the measure of angle BAC. That will be 2 times 34, and that will be 68 degrees. And that allows us to use the fact that the sum of the interior angles of a triangle is 180. So what do I mean by that? The measure of angle ABC plus the measure of angles BAC plus the measure of angle ACB. The last one, the one we need to find out, is 180 degrees. So we have here 54 plus 68 plus the measure of angle ACB equals 180. We're gonna add 54 and 68, and that will be 122 plus the measure of angle ACB equals 180. So one more step to find the measure of angle ACB, it's to subtract 122, that will be 58 degrees. But we did not finish, we have to do one more step for finding the measure of angle ECD, this one. We need to divide that in half. The measure of angle ECD is half of the measure of angle ACB, because that is an angle bisector. So we're gonna have 58 divided by 2, and that will be 29 degrees. So that is the first part of this problem. And now let's move to part B. Part B, we have to find CD. CD is this segment. Okay, this is 9. This is a right triangle. Now, if you remember, this is 7, so that means this is 7. So if you take a look, we have a right triangle there. This one. And we know this leg is 7 and this one is 9. We need to find this hypotenuse, so we can use a squared, Pythagorean theorem, plus b squared equal c squared. So we're gonna have here 7 squared plus 9 squared equals c squared. We're gonna have 49 plus 81 equals c squared. So that will be 49 plus 81. That will be 130. So C will be square root of 130. And C, like I said, it's nothing else than what we need to find out, CD. So we just need to take square root of 130. And round it to the nearest tenth if necessary, so that will be 11.4. In some cases, I said here, you'll have to use algebraic skills. So let's take a look to this problem here. We use the diagram below and find the value of x is if fd is 4 times the quantity x minus 3 and dg is the quantity 5 times 2x minus 6. But let's take a look first. What do you notice here? We notice these two angles are congruent, so AD is the angle bisector. These two angles are congruent, so this is an angle bisector and they intersect in this point D. So the intersection is this point D, and this is going to be the incenter, because it's the intersection of those two angle bisector. That means FD and DG are congruent, because those segments represent the distance from point D to the sides of the triangle. Okay, and the incenter is equidistant from those sides. So this is the justification of my algebra that will be after this step. FD, the measure of FD equals the measure of DC. So we're gonna have 4 times the quantity x minus 3 equals 5 times the quantity 2x minus 6. And here we're going to use distributive property. We have 4x minus 12 equals 10x minus 30. I will subtract 4x here to get rid of this 4x. So we have here negative 12 equals 6x minus 30. Add 30 to eliminate this minus 30, and we have here 18 equals 6x, and the last step divide by 6, and we have x equals 3. That is this problem, where it's very important to understand the point D is the incenter because it is the intersection of those two angle bisector AD and DC. Therefore, DF is congruent with DG. Okay, and my last problem here, I'm gonna write a proof about this angle bisector. That is in fact what we're gonna do here. Given ME is the angle bisector, so we know these two angles are congruent of NMT. Prove that E is equidistant from MN and MT. So let's draw this segment. This is the distance from point E to MT. Let's call it A. And this guy here is another segment. And this is, let's say, B. We need to prove that these two segments are congruent. So I'm gonna do a flow chart, and I'm gonna start from what is given. ME is the angle bisector of angle NMT. So remember, on a flow chart you make a box around the statement, this statement that is given, and that's the reason. From this statement we can go and write what? That the angle BME is congruent with the angle AME, and the reason is definition of angle bisector. Okay, and my next thing will be to write what? That let me change something in my picture to make more sense, which will be this angle is a right angle. And why this angle is a right angle? Because remember, this represents the distance from point E to the sides. So let me write that like this. Angle MBE congruent to, in fact, let me write measure of angle MBE equals with the measure of angle MAE, and those two angles are right angles. And how do we know that? Because what's the reasoning behind this? Probably I should write a previous step. Definition of perpendiculars. Perpendiculars lines. Okay, and that was the construction we had, right? We drew these two segments BE and EA. So now we know we have two right triangles, we have a congruent angles, and also we have a common sides. ME belongs to both triangles. So ME congruent with ME. This is what we call the reflexive property of congruency. And now from these three statements we can say what? Triangle BME congruent with triangle, and now we're going to be sure we write the corresponding letters, AME. And what's the reason of this statement? We have angle hypotenuse or hypotenuse angle. Okay. Hypotenuse angles theorem, if you want to call it like that, of a right triangle. Let me rewrite that, better. So we have two right triangles and the hypotenuse are congruent and one pair of congruent angles. So that means we have now those two triangles congruent. And now from this statement I can really say BE congruent with EA. And what's the reasoning of this statement? Corresponding parts of congruent triangles are congruent. And now obviously that means what we need to prove. E is equidistant from those two sides. Okay, and the reason will be here the definition of the distance, I guess. So I'm going to put here definition of distance. Okay, so probably the only thing I will probably add to this flowchart is another box here where I will say BE perpendicular on MN and let's say the same thing about EA perpendicular on MT. Okay, so we did construct these two perpendiculars, and that allows us to say the angles are 90 degrees. So maybe here I'll say construction. But this is idea of proving this angle bisector theorem. We notice the two right triangles formed are congruent by hypotenuse angle theorem. So obviously those two segments which represent the distance from point E to the sides of the angles are congruent. So the point E is equidistant. If you enjoy this lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.